Let's look at this one, which is the derivative of the sine and the cosine functions. I'm going to motivate it first for you graphically. I want to consider the graph of sine of x. And sine of x is the one that looks like the s, looks something like that from 0 to 2 pi, right? And so the idea is, what's the derivative of this function? Well, remember, the derivative of the slope of the graph, or the derivative is the slope of the graph. So if I looked at the derivative at this point, it would be about at a value of 1-ish. If I look at the derivative at this high point, that would be a value of 0. This point would be a derivative slope of the tangent line would be about a -1. This point, it would be about a 0. And this point, again, the slope of the tangent line would be about a +1. And what you end up seeing is that when you graph the slope of the tangent line, you actually end up with the graph of cosine of x. Really, really cool on that problem. So again, you can look at the Wolfram CDF player and download that to see that. But what did we just determine? We determined that the derivative of the graph of sine of x is super important. Or sorry, the derivative of sine of x is cosine of x. We could do the exact same thing with cosine of x. But if you look, it's a little bit different, because if we do the derivative of this function and we start looking at it, the derivative at the original point is 0, but then it goes to -1, 0, +1, 0. So it actually goes the exact opposite of sine of x, and that is negative sine of x. So the derivative of sine is cosine, and the derivative of cosine is negative sine. The derivative of sine is cosine, and the derivative of cosine is negative sine. And here's a little trick to help you remember. The derivative of the cofunctions are the ones with the negatives. So when we find the derivative of cosine, cosecant, and cotangent, those are all going to have negatives. Derivatives of cofunctions have negatives. So let's just write that as a little note here. Derivatives of cofunctions have negatives. So what happens on the test is you're like, okay, derivative of sine, I know it's cosine. Derivative of cosine, I know it's sine, but I know one of those is negative or positive. Well, anytime you find the derivative of an original function, sine, tangent, secant, those are going to be positive. Anytime you find the derivative of a cofunction, cosine, cosecant, cotangent, your answers are going to be negatives. So I hope that gives you a little jump on that to help you memorizing those, which ones are positives and negatives. So it says, find the derivative of the following function, y equals 2 sine of x. Well, the derivative of this would be y prime, which would be 2 times the derivative of sine of x, which is cosine of x. So the answer would be 2 cosine of x. Okay, we look at the next one. It says, find the derivative of sine of x over 2. Really what you want to think of that is 1/2 sine of x. It really is just a constant multiple. So my derivative y prime would be 1/2 times the derivative of sine of x, which again, the derivative of sine is cosine. So the answer would be 1/2 cosine x. Okay. Let's keep on going here. It says C, what's the derivative of y equals x plus cosine of x? Well, this is just the sum and difference rule on top of it. So our derivative, well, the derivative of x is simply 1. The derivative of cosine of x is negative sine of x. So this would be 1 minus sine of x. And let's look at D here. It says cosine x minus pi thirds sine of x. Remember, pi thirds is just a constant. So when I find the derivative of this, it would be the derivative of cosine of x, which is sine of x. Sorry, negative sine of x, right? And then it's going to be minus pi thirds times the derivative of sine of x. The derivative of sine of x is cosine of x. So I'm getting negative sine x. Then it would be minus pi thirds cosine of x. And that's my final answer. Negative sine x minus pi thirds cosine of x. Okay, let's move on to probably my favorite function to find the derivative of, and this is the derivative of e to the x, and it says the answer right there for us. It says the derivative of e to the x is e to the x. I want to motivate this graphically again. If you look at the graph of e to the x, the idea is think about so this is the graph of e to the x, right? Think about the derivative or the slope of the graph at any point is the slope of the tangent line, right? And it turns out that the slope of the line, if we looked at the slope of the line, like right here, the slope of the line is maybe 0.2, and then right here, it's about 1, and then right here, it's about 2. And it turns out that the slope of the line is the function value at that point. So again, the slope at that point is the function value at that point. Really, really, really cool function. This is a function that happens in nature that we just discovered. We didn't make it up. We noticed exponential growth happening with this base of e, 2.718, and goes on forever, right? This is a natural function in the world, and the rate of change at any point in time is the same as the function value at any point in time. So the derivative of e to the x is e to the x. Simply copy and paste.